Solving compound inequalities. Our objective is to solve compound inequalities in one variable, as well as graph solution sets of compound inequalities in one variable. Who uses this? A lifeguard can use compound inequalities to describe the safe pH levels in a swimming pool. Let's look at compound inequalities. All real numbers greater than 2 and less than 6. So your compound inequalities essentially are you're graphing more than one thing on the same graph. If it's an AND statement, you're going to be shading between. If it's an OR statement, you're going to be shading either to the left or the right. So you're going left or right. There's no overlapping of answers. So if it's an or equal to, you're going to have a filled in circle, same as your last lesson. If it's just a greater than or less than here, it's going to be an open circle. So once again, and your values overlap. So x is greater than 2 and x is less than 6, meaning that those values are all going to be overlapped. When you're dealing with an OR statement, none of the answers will overlap. It's either going to be left or right. A water analyst recommends that the pH levels of swimming pool water be between 7.2 and 7.6 inclusive. Write a compound inequality to show the pH levels that are within the recommended range. Graph the solutions. So, we're going to let P be the pH level of swimming pool water. So we have 7.2 and 7.6. So inclusive, we're going to basically go between, because we're going to include everything between them. So we have 7.2 is less than or equal to whatever the pH level happens to be, is less than or equal to 7.6, inclusive. You need to go between them, and you're inclusive, so you're including the 7.2 and you're including the 7.6. So let's look at this symbolically. So we have 7.2 is less than or equal to P, which is less than or equal to 7.6. And now let's look at a graph. Alright, so we have a filled in circle, because it's a less than or equal to. So we have a filled in circle on 7.2, and a filled in circle on 7.6, and all of our values are between those two. You can graph the solutions of a compound inequality involving AND by using the idea of an overlapping region. The overlapping region is called the intersection and shows the numbers that are solutions of both inequalities. So, x is less than 10. Well, those are all the values. X is less than 10. X has to be greater than 0. This graph shows all the values are greater than 0. So if you combine the two, x is less than 10 and x is greater than 0, you end up with an overlapping region. And that overlapping region is what you're looking for. Let's look at solving compound inequalities involving AND. So we have 4 is less than or equal to x plus 2, which is less than or equal to 8. So think of it as an AND statement. So you have 4 is less than or equal to x plus 2, and x plus 2 is less than or equal to 8. And then just solve them separately. So you're going to subtract 2 from both sides, leaving you with 2 is less than x, and x has got to be greater than or equal to 6. So once you have that, you can start graphing. So let's graph the first one. So 2 is less than or equal to x. Alright, well now let's go with the next. So we have x is less than or equal to 6. And in the end, we now have our overlapping region. So 2, 6, overlap, filled in circle because it's a less than or equal to, greater than or equal to, less than or equal to our x value. And that would be how you graph compound inequalities for and. Let's try this next one. Instead of writing them out separately, you can also keep things together. Keep in mind, you have more than one side of the inequality. You've got a left, a middle, and a right. So you want to keep everything balanced. So instead of just going, okay, subtract 3 from this side here, which is in the middle, and the right, you want to make sure you do it to all 3 parts because there's 2 inequality symbols here. So we're going to subtract 3 from all of them and then simplify. So we have negative 5 minus 3 is negative 8, which is less than or equal to what's left, 2x, is less than 9 minus 3 is 6. And then do the same thing again. So you have this 2x, you want to get x by itself, so you're going to divide all 3 sides by 2. And when you divide all 3 sides by 2, you end up with negative 4 is less than or equal to x is less than 3. So you can do them either way. You can write it as an and statement and then do it as though you have an inequality that says negative 5 is less than or equal to 2x plus 3, and then do another one that says 2x plus 3 is less than 9. Or you can do it all together. Either way, you will get the right answer in the end. So you can graph each piece separately. So you have negative 4 is less than or equal to x. X is less than 3. And then put it all together. So you have negative 4 and 3. Keep in mind you have an open circle because that one's not an or equal to. And then shade where it overlaps. You can graph the solutions of a compound inequality involving OR by using the idea of combining regions. So very similar to what you were doing for AND, only the combined regions are called the union because they're separate. And show the numbers that are solutions of either inequality. So if we had x is less than 0 and x is greater than 10, there's no overlapping region. So you would just put both of them on the same graph and shade accordingly. Let's try a couple. Alright, solving compound inequalities involving OR. Okay, so we want to get a by itself in this case. So we're going to add 4 to both sides and then add 4 to both sides for this one here, leaving us with a is greater than 5 or a is less than 1. Notice nothing's going to overlap. So we have a is greater than 5. It's an open circle and it's greater than. And then we have a is less than 1. So a is less than 1. And then just combine them. So we have greater than 5 and less than 1. Let's try another one. This one's a little bit trickier because you can't just do the same thing to everything. Because you have 2x is less than or equal to 6, and then 3x is greater than 12. So solve them as though they're 2 separate inequalities and then put it all together in the end. So we're going to divide both sides by 2, and then on this one we're going to divide both sides by 3. And simplify. So x must be less than or equal to 3, or x must be greater than 4. So when you're dealing with OR, it's generally easier to make sure that you keep them both completely separate, solve completely separately, and then in the end, when you graph them, put them together. So we have x is less than or equal to 3, and then x is greater than 4. And put them together in the same graph. So x is less than or equal to 3, and x is greater than 4. You don't have to put these 2 steps. You can just do the end step all at once. It's your choice. Let's look at writing a compound inequality given a graph. So now we're going to do what we were just doing, but backwards. Before, we were given an inequality and then we had to graph it. Now it's, okay, well, this is the graph, so what is the inequality for it? So we have two pieces that are, one's going to the left and one's going to the right. There's nothing overlapping, so you know it's going to be an OR statement. Doesn't matter what variable you use. So we'll use x. So on the right hand side here we have a filled in circle and it's shaded to the right. So x must be greater than or equal to, in this case, 7. And on the left hand side we have ourselves a -1 and x. So we have x and -1. And x must be less than or equal to -1. And you now have written a compound inequality. Let's try a couple more. Alright, this one, notice, things overlap. So we know that this one's like an AND statement. So our x is going to be in the middle. And now we have to fill in our ends. So we got 6 over here and a 0 over here. However, what should our inequality symbols be? Well, x has to be greater than, in this case, or equal to, because it's a filled in circle. And x has to be less than, and it's an open circle, so it's just less than 6. Take a moment and pause the video and try C and D. When you return, the answer will be revealed. So for C, we have an AND statement, so x is going to be in the middle. They're open circles, so you know they're not going to have an or equal to in there. So we've got ourselves -9 and -2, and we're going in between them. So -9 is less than x, which is less than -2. In D, we have no overlapping section, so we know it's an OR statement. And we have x is less than or equal to -3, or x is greater than or equal to 2. And that ends our lesson on solving compound inequalities.